Okay, we continue discussing on the application. The steps still same. When it comes to circular motion question, first step, look at the where is free body diagram. Go and find you draw the curve, then you find where is the center of step number 1. Step number 2, draw the axis according to the. So if you are very scared whether this is polar or non-polar, you just add in your question, your solution. You can still draw N and T, but add in 2 more axes in your diagram, which is R, theta depend on the motion. This is theta. If you scared you don't know how to solve, after you draw the center of the curve, you draw the axis of N and T. After N and T, you draw another 2 axes, ray R and theta. This is just in case the question asks you in the polar coordinate question. Then you can use V if V is given, so always tangent to the curve. Vt always tangent to the curve. Then you write the equation. The rest is either this set in normal tangent equation or polar coordinate, these 4 set of equation. You write either this one or this one. You memorize this 4 set. Then if it's polar coordinate, what you need to do? You need to do r dot, r double dot, theta, theta double dot. Go do differentiation first at the side of your answer. Do all these small steps, then only you look back at the equation. What is missing? So very easy one. So as long as you follow these 5 steps or 4 steps here, you should be able to solve any question. Okay, so you look at example 14. Rod OA is an L-shaped bar that rotates in the horizontal plane such as theta equal to t cube radian. In this case, it's radian. So what is the direction? This direction. Just follow the direction. Then at the same time, another object sliding outward because of inertia. You rotate these things, collar B will swing out on because of inertia. Sliding along with OA so that R is 100t square in mm. This one is in radian, one is in mm. So remember the unit. So if both case is in second, determine the velocity and acceleration of the collar, means the red color things, when time equal to 1 second. This question also don't panic. You need to focus what you need to focus on. In this case, what you need to focus on, rod OA or the red color collar. Red color collar. So go to the red color collar, draw a curve. This is sure a circular motion. This one rotate. Right? This one rotates. So go to the collar, or you just draw the collar, or you copy the whole axis. Then you go to the collar, draw a curve. Draw a curve. You should point to the center. You know the curve of center is O. Start with the center O. If you're scared, you start with N and T, then add one more. R and theta. R always pointing out. Theta following the motion, a direction. Okay? You know direction is this way. So your T and theta should be in this direction. After you complete this diagram, it depends. So this one, you see theta, you see R, so it's not tangent. But this one also no marks one, because the question give you theta and R, but if you scared, you write lah, just in case lah. If you feel safe, then you write. But this question, it asks you about R theta. Write this equation, these 4 equation. There's some component there lah. Write these 4 equation. Okay. Then after this, you know that this is a polar coordinate question. You need to solve for these 4 small things. You need to solve for R dot, R double dot, theta, theta double dot. This is a side homework or side steps there. You do side steps first. So you write R equals something, R dot, R double dot, just in case you forget. Then you write theta equal to something, theta dot equals something, theta double dot equals something. You just stand by the template like this. So without touching the diagram, you see, is there anything given or not? Theta is given, theta equal to t cubed. R equal to 100 t squared. You write this one, you do time differential dt, simple differentiation. So R dot equal what? 200 t, differentiate one more time, 200. This one, 3t squared, this one, 6t. What is the unit? This one, R equal to mm, so this one, mm over second. This one, mm over second square. Radian, radian over second. Radian over second square. Do this calculation. Then only you come back to the missing part, which is the diagram. Diagram, you copy whatever you see. Put in where is the curve. Focus on the object. You can draw the curve, right? You can draw the curve. So if you are scared, you just copy the shape of the rod. Put in the red object. Draw the axis if you want. Okay. So you draw R and theta. R and theta. Draw R and theta. Who don't understand why R here, theta here? Should able understand, huh? Understand? Yes, huh? R is positive going this way. Theta, why this direction? Because collar swinging this direction. So theta this direction. How you get the blue line? Huh? What is the equation of theta? T cube. T cube is roughly a parabola equation. Looks similar like quadratic. You can assume as a quadratic if you want. You just draw this line. Okay. Then you put in the velocity. In this case, you are not seeing t and n and t because this is polar coordinate. You know that this collar only have one direction to go. It is sliding along the rod. So you put in the v. Velocity always follow the direction or the motion of the object. In this case, it's sliding along this one. So you put in there vr, v sub r. Okay. So you vr, v theta, put in these two vector. Okay. Then completing the vector by parallelogram law. So you know that this is the resultant of velocity. Okay. So this is a resultant velocity. This one you can find, right? There's an equation for VR. There's an equation for V theta. Because you already know, you already do these steps already. So substitute the value there. You find this value, find this value. How to find this one? Magnitude, square this one, plus square this one, square root. How to find angle? In this case, either this way or this way using tangent direction or tangent equation, and so on. Okay, so this is add on the changes of theta. You just copy lah. This one you just copy. This is gamma. Is the one that you find the direction of the vector, because you don't want to mix this angle and this angle is a different angle. One is the rod angle, one is the vector angle. You can either put theta 1 here, theta 2 here, or gamma or sigma, like the symbol that I use here. Okay. Once you do, the question give you time. There's a reason there. It means it asks you to substitute at that particular time. So you do your differentiation, you substitute 1 second there is 100, right? So you substitute time here lah. 1 second, R equal what? R dot equal what? R double dot equal what? Okay. So after you do this one, if you have given time, substitute time here. E equal what second? This one is given usually. Substitute, you find this one. Also, you can find the T dot, T double dot. Okay. Okay, this line is mean substitution. Substitution. Any question for the value? No, right? So you have the R dot, R double dot. You do the same for the theta. Already do on the whiteboard here already. So again, substitute the time, all in radian. Again, you need to put in degree. You need to put in the layman term. Here, radian, put in theta. 2 pi radian equal to 360 degree. You do conversion. 1 radian equal to 360 divided by 2 pi theta. Now you multiply this constant with the p-value. Okay. So once you find the answer for r and theta, pull out the equation. The rest is just substitution. Pull out the equation. Pull out these two equations. Pull out another two for acceleration. Okay, we solve for v first. You can pull out the 4 equation, two for v, two for acceleration. The rest is just substitution. You can see here the rest is just substitution. VR we already find. VR is what? R dot. Where is this one? Put the 200, put here. Continue to write UR. Why this is a vector? Vector have magnitude and direction. Your V have two component, R component and theta component. Okay, substitute. R is 100. Theta dot, you already do the calculation. Theta dot equal to 3. So in this case, is in radian unit. It's in radian unit. Okay, in radian unit. Okay, so this is V. So this is V vector. You have magnitude, direction, magnitude, direction. From here, you can find the magnitude of V, right? Square this one, plus square this one, square root. Angle, same lah. You go back to the diagram, find the tangent here. Tangent of this one equal V theta divided by VR. This is tangent, triangular. Okay. Yeah. So same lah. I do it for you. The equation is like that. But remember the steps. Remember the standard SOP. Do until your muscle already remember it's actually doing this way. The numbers will change, the case study will change, but the steps always same. Okay, you have the magnitude of 600 something, 300 something, theta equal to 63 over something. Okay. So the total angle, don't stop here. Total angle of this magnitude or this vector is a summation of rod angle plus this angle. You calculate from rod angle, the purple color, and additional angle from here for the vector. This theta is for the rod angle. If the question asks you VR angle, VR angle is this one. But the question asks you velocity, which is a resultant velocity, which is this one. So give it this angle plus this angle. A bit tricky, but already show you how to do. You should already know to think in this direction. Same with the acceleration. You look at the acceleration, you put in A and R again. In this case, R is pointing that direction. R is in that direction. Okay, there's an angle you need to measure. Recall these two equations again. In polar coordinate, your AR always pointing to the center of the curve. Always pointing in the center. Same, yeah. So if pointing center is opposite of the R, so it will be in that direction. So just need to remember that one. Okay, you have your value here. R double dot you already do. R you know, theta dot you know, but remember it's a square of the angle only, not the R. Here also same, you substitute a value there. Okay, a bit lengthy, but the step is just substitution. After you get the value, you have one value here, one value here. Okay. Now don't scared if you get negative value. You get negative, it means it's pointing inside. Because R positive this direction. Yeah. So you have the substitution done. The next step is to find the resultant. Same. Square this one plus square this one, square root. Go to the diagram. You have the tangent theta over here. Tangent theta equal to this one and divided by this one. Get the theta. Okay, the rest is same. Answer for the A is 193 mm/second. Theta equal to 68.7 degree. But again, don't stop there. You need to consider the angle. So theta is 57.3 because 1 radian equal to 57.3 plus this angle. Okay. Negative 700. Oh, you mean this one? Okay. We only interested in magnitude because we only want to know how long is this one. When you calculate the triangular, the tangent, sine, cos, we only interested in this one. Negative in here is to tell you the direction, whether it is along the axis or not. It's a different topic. Okay. So you calculate angle, you don't use negative value. Huh? AR go inside because in our derivation, our R is pointing inside. Of course you can draw this direction. you can draw direction. But in your calculation, you'll come out as negative. You still need to flip the thing. Understand not? Okay, let's say from the starting. You draw in your diagram, you draw A theta and AR like that in starting. You solve question, at the end you get negative. A equal to negative 700 UR plus what? 1800 U theta. What does it mean? This one is R, right? This one AR, negative. So it should be, in the diagram, you should flip. In diagram, there's no negative value. In free body diagram or any diagram, there's no negative value there. Don't put negative value. It's only showing the direction only. Of course, you can put, in the beginning, you can put R this direction. But in the calculation, it will tell you what is the correct direction. Huh? 169, you take this direction plus this angle. 7.3, 57.3 is here, plus the collar angle, the acceleration angle. Sorry, it should be here, sorry. I labeled wrongly. I think lah. Is it correct? 180 is what? Theta. This is theta, right? Okay. Theta over this one.
That's it.
You press calculator. Wait. Sometimes you press calculator. Wait, we check. 90 minus 68.7 plus 57.3. Okay. Yes. 7.3. Okay. If I draw how do I say? 58.3. But you take this one, add this one, is get this one, right? Okay, it means is the total angle from this axis. Okay, this one, the R here is your measure from here to here. So here, with the from this axis, the differences from here to here is 68.7. Is this angle, right? This the angle that this resultant A moving. But you need to consider your rod starting from here, 0. When it start from 0, the angle of resultant will be 58.7. Before it start, it already start at 68.7. Can you see the A angle? This here is 68.7, right? So before it starts swinging, your acceleration magnitude already pointing in the 68.7 degree. acceleration angle. So when you swing, you adjust your axis like that. So how many angle that the A already moved? So you must add 57.7 plus the angle that you move here. So it's 57.3 plus the original angle. So the total is 169. Okay. This one plus this one, what do you get? Okay. Oh, I copy wrong already. How I get 169? Minus 68.7. 100 something. Okay, wait, 180 minus, or maybe it's this angle. Wait, 180 minus 68.7 plus 53.3. Oh, okay. Yeah. Okay. The angle actually is from here to here. So what is the angle over here? 180 minus this one, you get the magnitude plus this one. Then you get this. It's actually the same as what I explained just now. It actually is the same. Understand? Or it's still blurred? Okay, like that. This is A. Here to this is R. So this is 68.7. So here to here is 57.3. So the total angle is actually from here to here. So what is the angle here? 180 minus 68.7. You get one value. This value plus this value is 169. Makes sense? Yeah? I'm very fast. Understand? Okay, okay. Another one, this one, another new thing already. Another new section. This one is the fun thing. We start to look at pulley system. In civil, you use a lot of pulley system. All the crane, all the lifting devices, they use this system. This chapter, it asks you to find velocity of something if you pull using pulley. I will just summarize the steps and I'll explain slowly. Okay. For the second half, also SOP, when you see this pulley system, first step, what do? You calculate total length of the rope. Total length of the rope inside the pulley system. Okay. I just label as LT. LT equal to something plus something plus something. Later I'll tell you how to calculate this one. Second, recall how to find velocity. Next step is to find velocity by taking v equal to ds dt. In this case, dl dt. The third step, solving using any relevant equation. If you see pulley, no matter whether you know or don't know, start looking at total length first. Then do calculation for velocity. then you solve for the unknown. Okay. So in this case, you should be knowing the logic. If you pull the end of this rope, this one will go up. This one will go up. This one will rotate and so on. Okay. If you're seeing this diagram, okay, I need to put a note here. Remember datum in this question. If you look at this question, if I pull A, what happened to B? B go up. Okay. Remember the datum. Datum is from where you count your displacement. If you pull A, what happened to SA? Positive or negative? Positive. But you pull A, B will move up. What happened to SB? Negative. SB will become negative. Means SB will decrease lah. Okay. Okay, so this is the first thing. You know your coordinate of SA and SB. SA and SB from where? From datum. From datum. Okay. You measure from datum and you measure along the motion. This along the motion or along the floor. Just remember that. Okay. So positive sense. Okay, this one. You need to be careful of the arrowhead. You have a dot and arrowhead in the diagram. Or sometimes don't have dot, but you see arrowhead in the datum. It means the positive direction of that position. Okay. You see, SA positive going this way, SB going this way, positive. That's why when I say you pull A, your SA will get negative. SB is a vector. You going this direction, you get negative. Okay. Just remember lah, this one. As you do more and more exercise, this one you don't need to write already. You just need to know where is positive in the diagram. Okay, so how you calculate the total length in the system? You have point A, C, D, and B. The total length will be LT equal to SA plus CD plus SB. Right, this one. This is a standard procedure. First, you see any pulley system, you write total length LT equal to what you calculate from the diagram. In this case, it's a simple diagram, which is you write SA equal to CD plus SB. Next steps, you want to find the relevant velocity between one object to another object. How you find? This is a position. How you find velocity? The V equal to ds dt. This one you time differentiate it, it will become velocity. Okay, you time differentiate it. Okay, this one may be too fast. You ds dt, ds dt, ds db, dsb dt. But you ask yourself, along all the time, is there any changes in this length? No. So you can cancel out this LCD. For the position, you still you can as you go more and more exercise, you can ignore the red color region on the pulley. You can ignore the non-fixation. So this one, I jump a little bit fast. You write LT, for example, LT equal to SA, LCD or SCD, same, or SB. Then how to find velocity of something? V equal to dSA dt plus dSCD dt plus dSB dt. This one 0. Okay. The change of length Okay, the change of length, dlt or dt. Right, the whole equation you dt. So this one on the left hand side is dlt dt. Does the total length of the road change? Does the total length here change? No, it's no change. So this one 0 also. That's why you arrive at this equation. You get 0 equal to dsa dt plus dsb dt. Yeah. So for pulley system, standard operation, calculate the total length. Second one, you dt the whole thing. Dt the equation of the total length. Remember, total length doesn't change unless the question tell you the total length with the equation. Then you put your equation here. Leave question 0. Okay. You arrive at this equation. What is SA over dt? Velocity of A. The SB dt is velocity of B. You put them together, you get a relevant velocity. BA plus BB equals 0. You pull the DB to the right or right hand side, you get either one negative, one positive. It doesn't matter. Huh? As long as it show you logic. What logic? You pull A, velocity V go up. So it's in the opposite direction of B. Although both go up, one go down, one go up, but why B or A negative? Because SB positive this direction. That's why your velocity will be opposite of between the two bodies because of the datum direction. Okay, because of the datum direction. So this one may take some time to digest. So one downward, one go up. Okay. Same with acceleration, same. You d v dt, you still get acceleration. dv dt, you still get acceleration. Still same. Okay. The negative, it means opposite direction of the datum. Can Okay. We extend a little bit. Look at the system. Are you able to see where is the datum? Datum for A, positive this direction. Positive for B will be from this datum, go down. When you pull B, what happened to A? Will be moving this direction, right? So before solving, you should able to think logically the differences between the two objects. So if you put down, this one move here and the datum pointing this way, you'll get negative opposite direction of each other. Okay, so still the same. First steps, you calculate the total distance. Okay, this one you read lah. This one you read. Total will be what? Total distance of the length of the rope from datum. From datum. So how you calculate? SB. This one doesn't change, so you can skip. This one SB. SB plus SB, this one skip. Then this one continue with H plus SA equal L. Okay. After you find total, time differentiate this one. This one will become what? 2SB HSAL. Does the H change? So this one whole equation dt. This whole equation dt. This one got become velocity of 2VB. This one 0. h doesn't change, SA become velocity. This and this, okay, this and this become 2sp. Huh? No, you don't see rope direction. You ignore rope direction. It doesn't care how rope go up or go down. You more focus on the object. Focus on the object A or B. A and B. Okay. Okay. You arrive at this equation. You differentiate with time. You get 2VB minus equal to minus VA. What does it mean? You pull B, A will move fast or move slow. You pull B with, let's say, 10 meters per second. What is the speed of A? 5, not 20. Means double velocity of A equal to 1 velocity of B. Can you imagine? You pull this one, this one move. Okay. You understand, right? You understand the concept? No, because it's size. Because of the rope that traveled. You pull 1B already move 2 rope here. Plus the H doesn't change. You pull this one, you actually distance traveled by these 2 rope increase 2 times than here. Can you see? Okay, so it's important you understand what do you arrive for. Okay, you pull A means A move in one direction. Let's say A move in 10 meters per second. Your VV move in 20 meters per second. Double the speed of A. That is the reason. Or acceleration also same. Also the same. So standard steps now. First step 1, write the total length. Summarize the parameter. Then time differential the length, you get VB. Then time differential again, you get acceleration. Okay. I give you another example. You see left and right, what is the difference? What changes? No. What changes in the diagram? Datum changing. Datum changing. When you change datum, your solution change already. This is what we did just now. SB go down positive. SA go this direction positive. But now I change my datum from here, positive go up. Then datum go this way. What happens if I pull my SB here? So it will be SB negative. This one will be moving this way, negative, negative, actually same direction. Okay. So I just put side by side and I do the calculation for you. You do the same. Calculate the total length between B and A, between the pulley, between the pulley from the datum. This is a new diagram. How you calculate the length as A plus H. Then how you calculate here? H minus SB already. H minus SB equal here, you have 2. So 2 bracket H minus SB equal to the length here. Okay. Then you rearrange. You know that H doesn't change. You get positive value of A. You arrive at 3H, but H doesn't change in the time differential. You cancel out, become 0. You move around. Total length, you time differentiate 0. Total length doesn't change, so 0. You'll get positive 2VB equal to VA. The answer here is different from the previous one is because the change of datum. So be careful when you solve same setting, but if the datum change, there will be a different answer. Okay. Yeah, so just I have some mark there lah. Okay. 5 more minutes. We are quick one. How to apply? Still the same. You apply the steps here. First, you look at the total length. Doesn't matter how many pulley you see there. Calculate the total length for this diagram. Determine the speed of block A if block B have upward speed of something. So before you start, even before you start, you should able to imagine if you move A upwards, if you push this A upwards, what happened to B? Go down. But remember, you are referring to datum. Datum go down positive. But anyway, doesn't care as long as you focus on the datum. And then you start with the LT. How to calculate LT? Here, plus here, plus here, plus here. So you got, you write total length equal to SA plus 3SB. Okay, you can write SB plus SB plus SB. In exam, we won't highlight the red color for you. You need to be smart enough to refer to datum to datum. Datum to the object, datum to the object. In exam, we won't highlight the red color for you. Just remember that. First, the rest you read. The rest you read. You see the steps. This is just highlight. In the exam, you put or no put also, I don't give you marks. As long as you know where is positive and negative. You see how the solution, first you write LT equal to what plus what plus what. In this case, LT equal to SA plus 3SB. The next step is to time differentiate. The L, dt, there's no changes of length, 0. The S, dA become VA. 3SB dt become 3VB. Rearrange the equation, either put A on one side or B one side, doesn't matter. You arrive at this equation. Okay, it depends on the question, which one you refer to. Then you rearrange from here. In this case, you are given upward speed negative, upward speed 6 meters per second. Careless mistake is here. You need to refer to datum. Positive go down, but A is upward, so negative. You're looking at vector. So when you substitute value there, it's a negative, not positive. So if you pull your 3VB over here, it will be negative 3VB. You substitute 3 multiply a negative 3 multiplied by negative 6, you get positive 18. Positive 18, it means B, typo error here. It should be VB. VA. Wait. Oh, you are given block B, correct? Then VA, correct. Understand? Okay, if you understand, I will see you next week already. Next week is Monday. You have lab session, start this week. Your lab is under Dr. Reza.